My name is Steve and I'm a project engineer at Droid Technologies. And this morning I'm going to discuss with you how to set up a Mitsubishi VFD. Now, as we all are aware that there is close to 2,000 parameters on the VFD, to get your basic setup, there's only a few parameters that's needed and you can basically start up your VFD. But together with that, I'm going to discuss with you the differences between the two main applications. And that will be a constant torque application and a variable torque application. And then I'm going to do a quick setup using FR Configurator. Now, a constant torque application is where our torque stays constant, but it doesn't depend on the speed of the load. So whether you're running at, let's say, 1,000 RPM, 1,400 RPM, 2,000 RPM, your torque will stay constant. That is typically when you have conveyor systems, crane systems, machine tools, for example, a center lathe, a milling machine, and etc. Mixers, crushers, traction drives, and positive displacement pumps. These are typical examples when you would use a constant torque setup. Now, for this, we have a group of parameters to set up in the VFD to achieve a constant torque setup. First of all, we need to tell the VFD what is our maximum and minimum frequency for the application. If you have a fixed frequency that you're going to run at, for example, 50 Hertz, then your minimum and maximum frequency is going to be set to 50 Hertz. Your base frequency for parameter number 3 will be at 50 Hertz, as that is our supply in South Africa. Parameter number 9 will be the overload, and that we will set as per the full load current specified on the motor. Parameter number 14 will be our load pattern selection, and that we're going to set to 0 for constant torque. Our base frequency voltage, which is parameter 19, will be the supply voltage that's applied to the VFD. So if you measure 380 volt on your supply voltage, you'll put in 380 volts. If you measure 400 volt, you're going to put in 400 volt. Next up is parameter 29, and that will be our acceleration and deceleration pattern selection. And for constant torque, we're going to leave that at 0. Then we're going to jump ahead to parameter number 80, which will be our motor kilowatts. So if the nameplate says it's 100 kilowatt, you're going to put 100 kilowatt in. If it's a 90 kilowatt, you're going to put 90 kilowatt in. Parameter 81 will be the number of poles of the motor. So if it's a 2-pole, 4-pole, 6-pole, 8-pole motor, you're going to put that parameter or number against parameter 81. Parameter 83 will be the rated motor voltage, which by default is set to 400, but if your motor nameplate says it's a 380 volt, you're going to need to change that to 380 volts. Parameter 84 will be the motor rated frequency, and standard in South Africa, the motors will be rated at 50 Hertz. And then last of all, we'll do auto tune, where the VFD will basically measure the resistance of the windings and that will allow a much better control for the VFD over the motor. And that's basically what you're going to need to do a constant torque application setup. Now, a variable torque application is mainly centrifugal pumps, centrifugal fans, or blowers. Now, a variable torque application is when your torque is not, when your torque varies according to the speed of the application. Many types of loads require reduced torque when driven at speeds less than the base speed of the load. Such loads require increased torque when driven at higher speeds than the base speed, and it requires a lower torque when you drive at lower speed than the base speed. Now, that will be typically centrifugal pumps, centrifugal fans, and that's where we also get energy saving from on variable torque applications. To do a setup on the VFD for a variable torque will be very much similar as for the constant torque, except for two parameters that's going to change. Now, everything stays exactly the same, but parameter 14 will change to 1 instead of 0, and parameter 29 will change to 6 instead of 0. And that's the two parameters that will tell us whether you're running constant torque or a variable torque application. Now, if we look at a typical motor nameplate, the nameplate will have information that's important to us to program the VFD. First of all, we'll see the phases of the motor. It's a three-phase or a single-phase motor. And the base frequency of the motor. Second of all, that's important, will be the rated kilowatts. Then a lot of motors gives us two options of a star or delta connection. Now, in my example that I have here, the star connection is for when you have a main voltage of 400 volt. If your supply voltage is 400 volt, you're going to connect it in star and you'll have a current of 27.5 amps. If you're using a 230 volt three-phase system connected on the same motor, you're going to connect the motor in delta, but your amps is going to be 48.7 amps. The rated speed of our motor example is 2,910 RPM, which tells me it's a two-pole motor. Now, a very important thing when introducing a VFD to a motor is to make sure that the insulation class of the motor is of type F and higher. If it's a lower class, you'll need to consult with the motor manufacturer to see if you can install a VFD onto the motor. Now, if I take our motor nameplate and we say we're going to program the VFD according to that, we're going to set our maximum frequency to 50 Hertz, our minimum frequency, if we want it variable and we don't have force cooling on the motor, we don't want to go below 25 to 20 Hertz. Otherwise, we're going to heat the motor up and burn it out. Our base frequency, according to the motor, is 50 Hertz. The full load current for a 400 volt system is 27.5 amps. For a variable torque, we're going to select 1 for load pattern, which is a variable torque load pattern. Our base frequency voltage, sorry, I made a mistake there, that will be 400 volt. Our acceleration deceleration pattern, we're going to set to 6. Our motor capacity for parameter 80, we're going to set to 15 as it's a 15 kilowatt motor. And the number of poles of that applicable motor is a 2-pole motor. The rated voltage is 400 volts of the motor, and the rated frequency is 50 Hertz. Now, if I go back to parameter 19, I said I made a mistake there, but if you measure 380 volt on your supply, but you have a 400 volt motor, you're still going to put in your base frequency as 380 volts, but the motor voltage as 400 volts. And then last of all, we're going to set parameter 96 to 101. And that means we'll be able to do an online auto-tune. Now, when you do the auto-tune, you're going to need to make sure the motor is not connected to a load as yet. And the drive will start up the motor and start spinning it. And during that test that the VFD is doing, it's going to measure certain values inside the motor and record it on certain parameters. And that will allow you to run the motor a lot more sufficient. Now, FR Configurator is the tool that we use to set up the Mitsubishi VFDs. And when you initially open it, you're going to get a continuous list of thousands of parameters. Now, there's an easy way to change this, where you would go and create an individual list where you can select which parameters you want to see. And those parameters are the ones that we're worried about and want to set up. So on my filter selection, I'm going to select my individual list. I'm going to press OK. And those will be the parameters that we're concerned about to set up for this demonstration today. So on our default, I've read these values from the VFD. So just to confirm that, I'm going to do a batch read. Let's give it a second. So it reads through all of the parameters. And you can see it's reading 742 parameters at the moment. Not going to worry about that. And the current settings will be under the setting value tab. So our maximum frequency, we're going to change that to 50. And for this example, we're not concerned about running at variable speed. We just want to give it a fixed speed at 50 Hertz. Our base frequency is 50 Hertz already. Now, I'm using a 7.5 kilowatt VFD, so I can't program it as per the 15 kilowatt VFD nameplate. So I'm going to leave my amps at 17 amps. My load pattern, which is default 1 at the moment, I'm going to change to, I'm going to leave it on 1. My base frequency voltage, I'm going to change to 380 volts. And then our acceleration and deceleration pattern, I'm going to change to 6. Our motor capacity for in my case will be a 7.5 kilowatt. The number of motor poles, in this case it's not going to matter quite a lot, but let's say it's a 4-pole motor. The motor rated voltage we can leave at 400 because we don't have an actual motor connected, and our motor frequency at 50 Hertz. So once you've set all the parameters, then we can write them all to the VFD. Now you can do individual parameters. So if I select that parameter, I'll write as a single. But if I want to write everything that I've changed, I'll do a batch write. And it's going to ask me if I'm sure. Then it's going to go and write to all the parameters the changes that we've made. Let's just give that a second to finish up. While this is finishing up, one important thing to remember is that your VFD needs to be in the PU mode when you are writing parameters. If it's not in the if it's in the external or net mode, it will give you an error, and I can show you guys that. So I just want to change that back to 50, and I'm going to do a single write. And it gives me an error that error code that it can't write that selected parameter. If I change back to the PU mode and I write the selected parameter, now it's going to go and read everything quickly. I'm just going to cancel that for now. So now we have done a basic setup of the VFD. Now, if I change parameter 69 to 101, on the first startup, the VFD will do the auto tune. But in our case, we don't have a motor connected, so it will give us an error when we try and do the auto tune. Now, using FR Configurator gives us also quite a couple of nice tools where we can go ahead and test the motor. And I'm just going to change that to 50 Hertz. And if I unselect that and press forward rotation, the VFD will start up in forward rotation. Now that I can easily show you guys, through the built-in batch monitor. So as you can see at the moment, our output frequency is 49.98 Hertz. We don't have an output current as there's no motor connected, so we won't have an output voltage. Our frequency setting is at 50 Hertz, and because we told the drive the amount of poles that the motor has, it tells us it's running at 1500 RPM. Now, if I stop the VFD, I go back to my parameter list and I tell it, okay, now we have a 2-pole motor. I'm going to write that parameter. And I'm going to start it again in forward rotation. And now our batch monitor says that our machine speed is 3000 RPM, which calculates correctly. Now I can stop it from here, and I can also start it in reverse. And once it has ramped down, it will start up in reverse. And as we can see on our operation status, now the drive is running in reverse and it's back on 49 Hertz. Another nice feature will be that we can see our I/O on the VFD. So if you're having problems in the field, you can easily see if any of the inputs of the VFD is on or off. You can also monitor the outputs of the VFD. Now at the moment I'm running the VFD, so I have a on condition on inverter running. My up to frequency is on and my frequency detection is on. If we stop the VFD and we go back there, our up to frequency has switched off, and while it's ramping down, output frequency detection turned off and inverter running turned off. So it's an easy way of making sure that your inputs and outputs is working according to what you require them. We also have a function where you can go and read the lifetime of the VFD. So there's a procedure to it. For checking the measurements, we're going to need to power the VFD off and power it back on. Then it will go and read the lifetime expectancy of the VFD. I've covered the IO monitoring, which will be that. We also have an oscilloscope built into the VFD. Now, at the moment, I don't have a motor connected, so the values that we are going to get will not be very accurate. So I'm not going to go into that at the moment. And we are back at our parameter list. And that will be all that I'm going to cover for today. If there's any questions that you guys have, you are more than welcome to ask me now. You can also send me an email address or contact me when we're back in the office. If there's any questions, please feel free to ask. Otherwise, you are welcome to send me an email and with your related questions. I can also send you guys then a manual on FR Configurator 2, which will give you an overview of all the different functions and the capabilities of the software. If you require manuals for any of your current VFDs, please send me and send them through to you. If there's no questions from anyone,